As I mentioned before, we are going to see how the analogy we discussed is going to relate into the world of networking. We are going to connect that analogy into the application we've been looking so far. So drawing a similar diagram for our client and server. So we have the client here. We have seen this diagram before. So this is our client, the Python client. I'm not delineating between user mode and kernel mode and other operating system facts because we are having a discussion on layering. So I'm going to ignore all those operating system artifacts, including the fact that Python is there and it is in user mode. So we have the client here, and the client is talking to AFD, and AFD is talking to TCP/IP, and TCP/IP is talking to the device driver of the NIC card, which is the NDIS. The actual driver is an NDIS mini port, but we don't care about that kind of details here. And then finally, the card itself. Similarly, for the server computer, so this is the client computer. Let me draw that. So this is the client computer. This blue box is the whole computer, including the card. Now, this is the server computer. Again, another box we are drawing for the server computer. So this is the server. Now in the server, also we have the server program, which is in Python. Then server also has the AFD, same driver. We have seen that in the tools. Again, same TCP/IP is also here, and NDIS is also here. So these names, especially AFD and NDIS, will change in different operating systems, just a name change, but it does pretty much exactly same thing. You need to have code written by someone to do these things. It doesn't matter whatever name they call it. Especially AFD and NDIS is very Windows specific. The reason I'm using these terms is because I need to show you something very concrete, because a lot of the trainings, they just talk about OSI layers and things like that, which doesn't exist in real world. So I'm being as concrete as possible, taking a very solid non-abstract example, which is Windows in this case. So NDIS in our case, and then of course the card itself, the hardware. Now as you can see, the client is sending the traffic to the server. There is this connection. The connection is really a virtual connection between the client and server. In fact, the only physical connection is the signals which goes between these cards. The Wi-Fi signal in our case, through the iPhone we had. That is the only physical thing happening. Everything else is virtual. Virtual in the sense that the data is being transferred. The letter which Alice was sending is coming to Bob. But is she going there and giving to him? No, it is going through the truck. Similarly, the actual physical connection is between two cards through the iPhone. But the client feels that it is talking to the server. Similarly, in the case of AFD, pretty much TCP/IP is handling similar traffic to AFD. For example, the SYN/SYN/ACK. AFD didn't get all those packets. TCP/IP swallowed it, which means that TCP/IP is abstracting all the details from AFD. So AFD is also talking to the AFD on the other side from a virtual perspective. Same with TCP/IP. The SYN/SYN/ACK, that is a conversation between these TCP/IP drivers in the system. No one else in the system understand what is a SYN/ACK packet. It doesn't mean anything to anyone else. It doesn't mean anything to the client. It doesn't mean anything to the AFD. It doesn't mean anything to the NDIS or the card. A SYN/SYN/ACK packet has any meaning only for this driver. And it has to virtually talk to the peer on the other side. For example, you are sending a big truck to the local post office. He doesn't know what to do with that truck. He doesn't even know how to open the door of that truck. It's like that. To operate the truck and take the boxes of letters from it, only a warehouse can do it. Like that, the connection, the virtual communication between the layers has to be done by the virtual peers. In this case, it is TCP/IP. Similarly, NDIS and card, it's all one and the same thing. It's a physical layer dealing with shuttling bits of data whatever ones and zeros comes here, it has to come exactly as it is here. So that is the single most important purpose of the NDIS layer or the physical layer. Now, couple more points to notice here. The language talked between the peers is called protocol, or in this case, it is also called network protocol. So in our case, it is just hello world. So server understood what client is saying. It is hello world and server returned to it. There is no much of protocol in terms of AFD. It is just a function call interface, but the actual protocol comes in TCP/IP. So the protocol here is called TCP, and one more protocol which works on the bottom of TCP is called IP. Almost always these two protocols work in tandem. That's why we call TCP/IP. There are few protocols below the IP layer which works in the data link layer. We will get into that later. But to get a feel of protocol, it is again a very simple concept which we use in our daily life. For example, if you go to a restaurant, some of the restaurant, they serve the food. Some restaurant, you have to go there and collect your food. So that is a protocol. That is two different protocols to achieve the same thing. Like that, in the case of TCP, the peer of a TCP communication understand what it has to do when it receives a SYN packet. It has to send a SYN ACK. And the corresponding peer also knows what it has to do when it receives a SYN ACK. It has to send an ACK. That is part of the pre-arranged setup. Protocol is nothing but a pre-arranged setup. Both parties agrees and make sense to each other. IP is a very interesting protocol. We will discuss about it in later presentations. TCP also we will deal a little more in depth. There is another cousin of TCP called UDP. We will discuss that as well. But the idea of protocol is nothing but the peers between two systems in the network stack, in the layer, talks to each other. For example, I cannot send a SYN packet to the server directly. Server doesn't understand. Server understands hello world from the client. It doesn't understand a SYN packet. Remember that SYN packet didn't have any data inside. Server doesn't understand. So does AFD. It doesn't understand. So does NDIS. A SYN packet is just ones and zeros for NDIS. NDIS doesn't care about SYN or SYN-ACK or anything. It all cares about ones and zeros. It doesn't care. So the only guy who can understand a SYN packet here is this other side TCP/IP. So that is where the protocol comes into picture. The only person who understands you is the peer on the other side. Now, what if I send hello world to this TCP/IP from this client? Will it work? No, it doesn't work. TCP/IP doesn't understand hello world. It wants a SYN packet. If you don't send a SYN packet, it'll say, I don't know what you're talking. I don't understand the protocol. Now, another thing worth discussing here is the flow of the information. So AFD can handle a lot of different connects. So we had only one connect call. Like that, suppose if this client has many threads inside, we have yet to see multi-threading programs. We will see that. We'll make our server to handle multiple clients. Till then, we have not seen multi-threading. But suppose if the client has many threads and all the threads are connecting to different targets, AFD can handle it. AFD can handle any number of connect calls from a client. Like that, TCP/IP can handle any number of AFDs from different programs. So all the SYN packets from different programs comes into TCP/IP. It can handle all of those, just like the warehouse has a lot of those boxes to different destinations. TCP/IP get all kind of packets to different destinations. NDIS, which you see truck here, needless to say, it handles everything. All it cares is binary digits, read and write. That is the main thing NDIS does. So the AFD has all the connects from the client. TCP has all the AFDs in the system, the entire system. And NDIS has pretty much everything because it handles the binary data from the TCP/IP, just like in the case of post office. Now, again, the reverse happens when we come to the other system. So NDIS has everything. The TCP/IP handles pretty much all the information which is coming from the NDIS and divide between different applications. And finally, whatever is targeted to the server, it is given to the server, just like in the case of Bob. Bob was getting only one letter from Alice. Again, server can get any number of packets from other sources. That is also possible, just like Bob can get any number of letters. So that analogy is also applicable here. So to conclude, we have seen how the analogy relates to the networking. Let's keep digging a little more details of this particular aspect of the computer networking in the next lesson.